14 here. I didn't think you'd be back that fast. I wasn't even looking for you. Hadley. We need to go ahead and get started here. So obviously we have to adjust a little bit with our snow day from Friday. So just a moment ago I updated our slide with some new dates here. So we will actually be doing Friday's lesson now because you were not here for that. So our plan was to do this law of sines, law of cosines quiz on Wednesday because today was supposed to be like the review day. But since we missed one class, that means the quiz gets pushed back one class, and so instead of being on Wednesday of this week, it'll be Monday of next week. So buys you almost a whole extra calendar week to prepare. But today we need to go over law of cosines, similar to how we did law of sines. So law of sines last time, talked about what the formula was, what information you had to have to solve it, practice plugging in the numbers to solve for side lengths or for angles, and then there's a few applications. So same idea with law of cosines, but law of cosines is a different formula. It's not going to have sines in it, it's going to have cosines in it. And it solves with different information. If we did the exact same thing with the exact same information, we wouldn't really need the law of cosines like we need the law of sines. We'd have law of sines and that would be good enough. So, law of cosines, the parts that you will be on the hook for is we will have questions about when can you use the law of cosines, and that's when you have side, 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 or side, angle, side. So, this is of course when you have 3 side lengths of a triangle. This is when you have 2 side lengths of a triangle. And this A is between the S, so the angle you know the measure of has to be tracked between the 2 sides you know the length of. This would be called the included angle. So those are not scenarios for law of sines. I'm not going to compare and contrast law of sines too much today because that's a lot of what we will do next class. But remember, law of sines works when you have any two angles on one side. So angle, angle, side, angle, and side angle. So two different scenarios. The formula for law of cosine is these things. So I tend to use, they're really all the same version of each other. You could just algebraically manipulate one to get to the others. But I tend to use these if I'm solving for a side length. Like if I'm solving for A, I probably am just going to use this top equation. If I'm solving for B, middle equation, C, the bottom equation. Oh, I'm sorry, I forgot part of this bell work here. If you guys did not turn in the notes 57 and that like 9-question book assignment 58, if you did not get that in the Google Classroom like I asked last time, or for homework, you need to do that right now, because in a minute, as soon as we go over these notes, I'm going to finish putting in the last grades. So I'll pause here for just a second and make sure you have time to do that. Okay, looks like we're okay to go on. All right, and then the other three formulas are kind of set up if you want to find an angle. This one almost is angle A equals, just have to do inverse cosine of this. This one's almost angle B equals, just do inverse cosine of this. And this one is almost solving for angle C, you just need to do inverse cosine. So these are typically set up well to find angle measures, and these are typically set up well to find side lengths. But again, in theory, if you algebraically solve this for cosine of C, you would end up making it look like this. Now, one thing that is kind of important to talk about, and I'll bring this back up before we finish up with the notes, but one of these should look very familiar to you. This one. This one is almost a squared plus b squared equals c squared. It's almost Pythagorean theorem. Now remember, Pythagorean theorem only works on right triangles, whereas the law of sines and the law of cosines will work on oblique triangles. So that's triangles that don't have a right angle. So, I mean, of course, I'm not in charge of determining what you guys learn in geometry, but I always was kind of curious why you didn't just learn this formula instead of Pythagorean theorem, because this one always works, whereas Pythagorean theorem only works if it's a right triangle. Now the reason why it's that, I guess then I don't have to talk about it later, is if this is a right triangle, this ends up being the cosine of 90 degrees. And if you think about the unit circle, the cosine of 90 is 0. So when C is a right angle and it's a right triangle, you're left with Pythagorean theorem. But if C is not a right angle, adding that little piece there can help you find his side length. Of course, you would need to take the square root of both sides. So, like the law of sines, when we do this quiz this time next week, we do not make you memorize the formulas. I think it might be in your best interest so that you're more familiar with it on the ACT, but we will provide these for you. So, none of your challenge for this class, at least, is to memorize the formulas. But again, I think if you memorize one, you can kind of see a pattern between the other two. And if you memorize this one, there's a pattern for those two as well. That's how I memorize them. Okay, so this one always works. It's pretty straightforward, so we're not going to do a ton of examples. We'll jump over to the book assignment pretty quickly here. But here's one that was already typed up from the internet where someone was trying to find a side length. So you can see they called this side C, which makes this angle C. They started off with one of the formulas, plugged in the information given to them. I would just let my calculator do the next 3 steps personally. I don't think it's any easier to do some of this in your head and then some of this in your calculator, but you get all the way down to what x squared equals, And then of course to go from x squared equals to x, they just took the square root of both sides. So again, if you know the formula and you plug the numbers in correctly and your calculator's in degree mode, it's pretty hard to mess up because it works for all triangles. Okay, and then over here, here's somebody finding two of the angles. So here they're trying to find angle theta. Greek symbols are really common for angle measures. The main one we use is theta, but you can use alpha or beta or gamma. I think that's gamma, I'm not sure. But same thing. So notice they wrote out the formula. They plugged in the numbers where they were supposed to go. That's going to give them a number from -1 to 1 because you didn't solve for angle alpha, you solved for the cosine of alpha. And then just like with the law of sines formula, I'm highlighting this part because this is the part that I think some people will forget and will hurt quite a bit. You need to do inverse cosine of that to actually get the angle. If you wanted angle beta instead, the formula is just some of the variables are in slightly different spots, so the numbers go in slightly different spots, but same thing. I would just do inverse cosine of this from the beginning and be done. But just remember, this will guarantee to be a number between -1 and 1 because this is not beta, this is cosine beta. You have to do inverse cosine of that to actually get the answer. Okay, and I had mentioned something called an ambiguous case, just for your own knowledge here. Ambiguous case only exists for law of sines. Law of cosines always works. Okay, the other thing we squeeze in here, and we'll do a couple practice questions on the back and then we can jump on, not a lot though. So there was an area formula I showed you last class, but you have the one from geometry, the one you're familiar with, but if you know side angle side, the one I showed you from section 6.1 was you could do 1/2 times 2 of the side lengths times the sine of the angle in between them. Again, we provide the formulas, so you don't need to memorize the formulas. Although I do think this shows up on the ACT, and of course you have to be fairly familiar with it to do it on the ACT, so maybe you still want to do it. The new one for section 6.2, this one's called Heron's formula. This is a really famous formula. Also kind of surprised you don't learn this one in geometry just because it's so easy. This one works if you know all three sides of a triangle. So instead of you doing the work and right triangle trig and solving for the height, you can just plug in these side lengths. So his formula says, this is the first time I've shown this one to you, the area of a triangle is equal to the square root of s times s minus a, where a is one of the side lengths, times s minus b, where b is the second side length, times s minus c, which is the third side length. So of course your next question should be, what is s? S stands for semi-perimeter. So perimeter means you add up the lengths, and I usually ask my classes this to see what you guys would guess. Divide by some number. Most people guess 3, and I get why you're saying 3, because that would be like an average. If you're adding 3 things up and dividing by 3, it's an average. But this isn't average, this is semi-perimeter. Just like semicircle is half of a circle, it's only divided by 2. Okay, so let's actually skip to the question that asked us to practice on the back page so we can discuss that, and then we can backtrack and do the other two. Okay, question 3. Find the area of this triangle where one length is 16 feet, one length is 22 feet, and one length is 9 feet. So Heron's formula says I'm going to do s times s minus one length times s minus the second length times s minus the third length. Then I have to compute s, which is half of the perimeter. Calculator doesn't necessarily have to be in degree mode or anything like that, but S is 23.5. If you plug that into the 4 spots where there's an S, I can just type that in my calculator just the way it looks. And that gives me 61.915. And since that's area, it would be feet squared. Always works. And if you have a calculator, again, it's doing the arithmetic for you. You just have to know the formula to be able to use it, which we will provide for you on the quiz, so that's not an issue for our class at least. And how to find S. And just practice plugging it in. So definitely one of the more useful area formulas. Okay, any questions about Heron's formula before we backtrack and look at the other two? Okay, then number 1 is kind of a trick question, so this is only going to take just a second. But if you start plugging these numbers into the law of cosines and solving for angle A, angle B, angle C, you're going to get some error messages. Your calculator is going to try to tell you that something's wrong. So with this one, I was just trying to point out to you, I used to teach a lot of geometry, so this stuff's kind of important to me. But you can't just pick whatever lengths you want and make a triangle from them. If A is 10 meters and B is 13 meters, or I'm sorry, 3 meters, the only way for C to even connect all of these things is for them to all be flat like that. That's the only way those things are going to connect, which of course doesn't even make a triangle. The thing you should have learned in geometry, bless you, is that when you add the 2 smaller sides, they have to be bigger than the biggest side. Otherwise you can't have a triangle. This was even 13, or I'm sorry, if this was 3.1, then that would give me just a tiny bit of leverage to actually make a triangle out of this. Okay, but then the second one actually uses the law of cosines. So it looks like we have side A, side B, and angle C, and we're asked to solve. So of course that means find everything else. Just like the law of sines, you are more than welcome to make a quick generic triangle ABC if the visual helps you. But because this is side angle side, this is set up to find a side length. So I could start off by finding C by using this formula. Personally, I think it's a good idea to take the square root immediately so you don't forget about it. But you plug in length A for A, you plug in length B for B, you plug in length A a second time, you plug in length B a second time, and then you take the cosine of the angle opposite the side you're trying to find. Assuming your calculator is in degree mode, and assuming you don't fat finger any of the buttons, that's all there is to it. I don't think this should matter, but when we do the quiz, we will insist that you guys write out your work. This is like the only work you can show, so whatever's getting thrown into the calculator is the work. Okay, I will store that in for C in my calculator so that I don't have a decimal. But now if I'd like to find angle A, I could look up the part of the formula that says this. And someone will have to double check me here because is that correct from the front page? Okay, I thought so, but I didn't want to work it wrong. So same way I started off with the square root here, I would suggest that maybe you start off with doing inverse cosine so you don't forget about it. Plug in length B for B, plug in length C for C, that's what I had up here. Plug in length A for A, plug in B a second time, plug in C a second time. And once again, assuming your calculator is in degree mode, and this one's going to make some of y'all miss some of the questions, and this is going to be what your problem is, so you can fix it right now. You either need to put the numerator and denominator in parentheses, otherwise your calculator is going to do division here before it does this add and subtract. Your calculator does order of operations very strictly. Or you could do alpha y equals 1 to put it in as a fraction. So let me type this in my calculator so I can see it, and then I'll show you on mine. Okay, what I mean by this is, and this is pretty much the only way you're going to miss a lot of cosine questions. If you type it in like this, well, hold on. I had stored that in for C on my calculator. Okay, a lot of you guys are going to do this. And there's a good chance this is going to give me an error message. Okay. Problem is, well, the error message is because this is a number. Oh, well, I also didn't type it in correctly. It should be at times. If this is a number outside of -1 to 1, that doesn't make sense, and that's why the calculator is throwing a fit. The reason why it's giving me an error, and it shouldn't though, is again, your calculator does order of operations very strictly. So it's going to do exponents first, then it's going to do the first division, then this multiplication, then the multiplication, then it's going to add, then it's going to subtract, and that's totally out of order for what you want. You have to make a habit out of doing parentheses around your numerator, that forces it to compute all of that before it does this division. Parentheses around your numerator and parentheses around your denominator. And then that's where I got that. By the way, even if it's a really basic fraction, it does not hurt to put parentheses around the numerator and parentheses around the denominator. It takes an extra second to type it in, but a lot of times you catch that mistake. The other way, and I'll show this one time, I didn't really use this too much until maybe last year was probably the first year I used this a lot. But if you do alpha y equals, this first option says numerator over denominator. So it lets you like type it in the way it looks on your paper. And in mathematics, when we do this big fraction like this, a big fraction, it's implied you do all the numerator and then all the denominator and divide. There's implied parentheses, we just don't write them all the time, but that's okay too. So parentheses around the numerator and denominator, or type it in with alpha y equals option 1, make it look like a fraction. But if you do it the other way, if it gives you a number, the number's not going to be correct, but more than likely your calculator is going to have an error. Okay, and that is angle A. I don't think I need that, but the last thing would be angle B. So once again, slightly different formula. Numbers get plugged in a slightly different spot. And I'm just putting generic C there because I stored this in my calculator earlier so that it would be exact. And then again, you need to be in degree mode, and you need to make sure you put it in your calculator correctly, either with parentheses or as a big fraction. Otherwise, what it gives you, shouldn't have to question it too much. Now, can anybody think of an easier way that I could have found this angle B? Right, at that point you knew 2 of the 3 angles, so you really could have subtracted those from 180 to find angle B, the last angle. That's still true, but notice the benefit of this. Because I went ahead and did this, I can feel much more confident about my law of cosines work, because angle C plus angle A plus angle B, those added up to 180 without me forcing them to 180. They just naturally added up to 180. So that makes me feel pretty confident about how I typed it in the calculator and how I set it up. So, but again, that's pretty much it. The formula, if you're trying to find a side length, A, B, or C, should start off with one of these. Probably should start off with the square root so you don't forget about it. Plug the numbers in correctly, hit enter. If you're trying to find angle A, angle B, angle C, use one of these. Probably start off with inverse cosine so you don't forget about it at the end. These are the ones that are very calculator picky. Because of this division sign, it is easy to not type it in correctly with order of operations. That's one of the things you need to make sure you have straightened out today. Okay, so the book assignment, again, just like the law of science, is pretty short because honestly, after you do a couple, there's not anything really different I can throw at you to make you think about. So, on blank piece of paper, or I guess you could do it on the back of the other 6.1 book assignment is fine, but if you number this one as 61, there's 9 book questions. And as usual, I'll give you a 10-15 minute head start, interrupt you to help you figure out some stuff that you can see is messing you up. But finish up the bookwork first. Turn in the bookwork and the notes into Google Classroom, and then you can start on the worksheet. If you don't finish the worksheet in class, you can finish that up for homework. You can see it's short too. Okay, so please try to get a couple under your belt in the next 10 to 15 minutes so that if you are having a hang up, I can help you and keep you from having to do a lot outside of class. Which angle? Squared plus c squared. This would be minus a squared. Now that you've had time to try the first question or two, is there either question 5, question 9, or 37? Sorry?
You do question 5.
Number 5. Okay, question 5. Let me see if I need this one on the website. Do not. Okay, I'm not going to make the picture for number 5 since you've got it in your book. But this one gives you 3 side lengths. They're asking you to solve, so they want you to find the other or all 3 angles. So for angle A, you would want to pick out the formula that says cosine of A is equal to. Of course, you want to make sure you look at the formula correctly, just because we are providing you the formulas and they're on your notes. You know, if you plug in a number in the wrong spot, or you forget this 2, or plus becomes a minus, anything like that, it's going to confuse you for a few minutes. So what I would put in my calculator and the work I would expect to see on your paper is A is coming from inverse cosine of 12 squared plus 16 squared minus 10 squared all over 2 times 12 times 16. Once again, this has to be put in the calculator correctly with parentheses or as a fraction. Otherwise, it is going to do order of operations in an order different than what you intend for it to. And again, that is a very common mistake here at the first. That's why I'm trying to bug you so much about it. Okay, and then my calculator is telling me that's about 38.625 degrees. So I don't really have anything to compare that to, so I would just have to assume that that's okay. For angle B, it's going to be almost the exact same work, but slightly different formula to start off with. So B is going to come from inverse cosine of, let's see, his would be A squared plus C squared minus B squared over 2AC. In fact, I'm just going to let my calculator do the same thing it did before. I'm just going to go back and have it change a couple numbers. The 10 and the 12 switch spots. That's basically it. Okay, and then it tells me this is angle B. Okay, now I have something to compare it to. I know side B was a little bit bigger than side A, so angle B should be a little bit bigger than angle A, so that seems reasonable. Now, on a quiz, if you were about out of time, you could subtract these two from 180 and get angle C, and that's perfectly fine. That always works in mathematics, so you don't have to use law of cosines a third time. But the benefit is, first off, especially in your book practice, it's a little more practice of using the formulas. If you go back to what you had typed in, you really only have to change a couple numbers if you don't want to type the whole thing in again. And the benefit of finding, okay, the third angle is it gives me some check here. That number does not make sense. So I must have typed something in incorrectly. Let me check my work. Oh, I put put this in the wrong spot, didn't I? C would be a squared plus b squared minus c squared. Okay, that looks a little bit more reasonable. And again, personally, I like to find that last angle with law of cosines, not because I need the extra practice, but if I find all three angles with law of cosines, and in the end they all add up to exactly 180 degrees like they're supposed to, then that almost guarantees that you did it correctly. It's very unlikely that one of these is wrong and the other one balanced it out perfectly. But the mistake I made on this last angle is I just didn't plug these numbers in correctly. I was going a little bit too fast, so try to learn from my mistake there. Okay, was there something more specific there? Okay, anybody else going to ask about number 5 before I give a chance for another question? Okay, anybody need any parts of 9? And then 37 was Heron's formula, the area for it.
Could you show me how to find angle C for number 9?
Sure. Okay, so without looking at question 9, I know we should be looking at this formula. So our answer should come from inverse cosine of a squared. Okay, do you have a already?
Yeah, it's 18.59.
Okay, now that's rounded a little bit, so this is going to be off a little bit too, but plus b squared minus c squared over 2 a b. I'm getting about, again, this is going to be a little bit off because you gave me a rounded answer here, but this is about 126.204 degrees.
I think I just typed it in wrong.
Okay, my guess would be that you probably either needed parentheses or put it in as a
Yeah.
fraction. Yeah. Okay, let me give you guys, again, there's not like a million tricks to this. If you can find a side, you can always find a side. This is more or less just a few practice questions to help you make sure that you know what you're doing before you get an assessment on it. But if you can find a side, you can find a side. If you can find an angle using one of those formulas, you can find an angle. And then Heron's formula, same thing. Always works. So if you can do it 2 times, you should be able to do it 20 times. But I'll give you a little bit more time. Obviously, I'll let you ask some more questions, but as you guys finish up the book work, again, please turn in the notes and the book work to Google Classroom for me. is what you need to, and then you pick whatever formula you want.
Great, thank you.
Okay, let me offer some help again. So 37, 39, both use Heron's formula. 45, 47 were law of cosines, but just find a specific side or a specific angle instead of everything. Oh, yeah, we'll definitely have to talk about 52, but we might wait a few minutes before we get there because I don't know that everyone's there yet. .53 looks like an angle, law of cosines, and then 61 is true false about one of the formulas. So any of that I can help with yet besides 52. Hold off on 52 just a little bit longer. Yeah. 53. Okay, 53. Triangular parcel of land is 115 meters, 76 meters, and 92 meters for the boundaries. What angle does the frontage make with the other two boundaries? Okay, I'm going to assume they're talking about, if they're calling this the frontage, I'm assuming they're going to talk about this angle for the frontage. I'm not 100% sure on that, so I'll have to double check the answer as we finish. Okay, but notice they didn't call things A, B, C, so if it helps you, feel free to make them up yourself. So based on how I name them, I would be finding angle A, which would be inverse cosine of b squared plus b squared plus c squared minus a squared over 2bc, and I think that should be it. I'm getting about 85.838. Did you check the back of the book yet? I just want to make sure that's the right angle since they weren't very clear.
I think it's asking for the other two, B and C.
Oh, what the other two? Okay. So I guess I did this for nothing, but I guess I can use it as a check in the end. So if I want C, inverse cosine of a squared plus b squared minus c squared over 2ab. So it looks like we got about 53 degrees for angle C. Okay, and for angle B, it would be inverse cosine of a squared plus c squared minus b squared over 2ac. Also, let me show you guys a quick little calculator trick that I'm doing a little bit here. I think some of you guys know about like moving your arrow up and selecting something to get it to retype it in for you, and that's okay. But another way to do something similar is I'm doing this on my calculator, it's making it much quicker. If you hit second enter, it always pulls up the last thing that you typed in, and then you can just keep spamming second enter, and it just keeps typing in the thing before that, the thing before that, the thing before that. I don't know, up to like 10 things or something. So if you just need to basically type in the same formula and you just want to change a couple numbers, sometimes it's quicker to just second enter to pull up the last one and then go and change a couple numbers than to type the whole thing in again. Okay, so finally I put that one in. I'm getting this. Again, this was pretty much worthless, except since I did find one extra angle, it does give me a chance to add these up and make sure that they add up to 180 degrees, and they did. So, and not just close to 180. Close to 180 sounds good, but if it's close, then that means you might have misrounded one or two of them. They should add up to exactly 180 if you rounded them all correctly. For anything that rounds up, the other ones should round down. All right, Caitlin, is that all right? Okay. Anybody else need to ask about 53 while still up there? Okay, let me give everybody about 3 minutes here, and then we'll all look at 52 at the same time. There's one thing in 52 that I've not told you before, so I can't expect you to do that one yet. Normally, we have shown you that in the past at this point in the year, but just not now.
So, I had done the 691 buck for some reason, and my phone said it was turned in. I'm getting a new one because my phone's not been working good recently.
Okay.
But I'd already done it completely.
Okay.
And I just turned it in.
Okay, I saw that, and I already commented. You didn't put work on the last two, so I need you to attach that.
Okay.
And then I'll give you the points for it. Push. All right, let's go ahead and look at this one together. The number 52. Again, there's part of this that I have not shown you before, so if you're not to that point yet, you need to jump ahead to it. It has a couple of bearings in here, but these are not the same type of bearings that you have seen in the past. The type of bearings that we have used up to this point give you like directions, like start at this line and turn this much towards this line. Bearings can also just be a number. So like the first one says bearing of 75 degrees. So if it does not give you directions, like this one, then it's assumed that you're starting at the north line always and turning clockwise. So for question 50, I'm going to erase this in just a second, but the first airplane is going 810 miles from Franklin to Centerville with a bearing of 75 degrees. So from the north line, measuring clockwise, if I turn 75 degrees, that's going to look like this. I know this is 75 degrees. Likewise, I don't know if I need to know it, but I know these two make a right angle, so I know this one's 15. That might be helpful. I'm not going to write it on here until I actually think I need it. But when it does not give you directions, you have to know this. North line measured clockwise, however many degrees it says. So this plane is going 810 miles. It's going from Franklin to Centerville. Okay, then it flies 648 miles from Centerville to Rosemont and takes a bearing of 32 degrees. So now from this one, it's a bearing of 32. So from the north line, turn 32 degrees clockwise. So that would roughly look like this, where this is 32 degrees. It's 32 degrees away from the north line. That's always assumed if they don't give you the directions. If they tell you north something east, then follow the directions. But if it doesn't tell you and it just says bearing, you assume north line measured clockwise. Okay, and then that one was 648 miles, and that was to a place called Rosemont, so I'll call that R. And with this information, they would like us to find the straight line distance and bearing from Franklin to Rosemont. So if you just went straight, how many miles and what bearing would you take? All right, well, first off is I think I'm going to need a little bit more angle information. So personally, I'm going to use alternate interior angles. So I've got a north-south line here, a north-south line here. So those are guaranteed to be parallel. This angle of 75 is in the top left in the interior. So he's going to alternate with the bottom right in the interior. So this one is also 75. Of course, it also makes sense to kind of eyeball them and make sure they look the same size. If they don't look the same size, then you might be picking out the wrong angle. If this is 75, I can figure out the rest of this angle because together these two make up half a circle. Half a circle is 180. So the rest of this is 105. And now I know law of sines, I'm sorry, not law of sines, law of cosines can get me this answer because I have a side length, an angle, and a side length. I have side angle side now, and that is a condition for law of cosines. I'm going to call this side A. So his length is going to come from one of the lengths squared plus the other length squared minus 2 times the first length times the second length times the cosine of the angle opposite those, which would be, this whole angle would be 137. 105 plus this part 32. This whole angle of the triangle is 137. So honestly, the law of cosines part is probably the easiest part of this whole question. Making the figure, carefully drawing in the bearings so you don't mislead yourself, finding another angle, Almost 1,358 miles. Which is of course longer, but I don't know. I don't like to fly very much, but those of you that do fly, if you notice, whenever you have layovers and stuff, you go into all these extra cities, it ends up taking more time than if you could just go straight there. Going straight there is obviously the most efficient path. So 810 plus 648 is definitely going to be more than that. So. Okay, and then for the bearing part, so they want me to describe the direction that this guy is going using this. So I could say from the north line, I'm turning to the right. So that would be towards the east, so many degrees. So if I can figure that out, this would be an acceptable answer. To find this angle, let's see, I know this is 15. I know this is part of 75, but I don't know exactly how much yet. Well, I know there's one thing I could do. I was trying to avoid it, but since I know all three sides of this triangle now, I could find this angle with law of cosines, and then if I know these two angles, I could subtract those from 180 to get this one. I was hoping there would be something a little bit more efficient, but I guess not, or I don't see it right away at least. Okay, so I'm going to find this angle R. So that would be this side plus this side minus 810 squared over 2 . I think that should be how it's set up. Again, you can always label these angles ABC, and then you can pick out a formula that looks exactly like that if it makes you feel more comfortable. Okay, so that comes out to be about 24 degrees. Would be this one. Okay, now if I know this is about 24 and this one is 137, I could subtract those from 180, which tells me this angle is almost 19 degrees. That would be this one. So that was almost 70 minus however much this was. So how much of a turn was 75 minus that, which gives me about 56.006. Or if you don't want to, you're welcome to write a bearing this way because it doesn't say you can't. But if you just want to use the word bearing, again, it's assumed you're starting at the north line and you're turning clockwise. So this would be okay too. Those two are saying the same thing. Again, I still think there might have been a little bit more of an efficient way there at the end. But at the end, you have to know what those bearings look like for the picture. I found one more angle using alternate interior angles. I saw that I had side angle side, so I threw those numbers in the law of cosine. to find the last side length. That was one of the answers that they wanted. And then since I had all three sides, I could use law of cosines to find the last side. Sorry, the last angle. And then once I knew all three angles, I could figure out how much of this turn was of that 75. 75 was this whole thing. And so once I figured out this one was about 19 of it, I figured out the rest was about 56 of it. And so that's where the bearing came from. That's what we call an angle chase question, where you got to find one angle so you can find something else, so you can find something else. But that might be a good one. I know this is a really short assignment. That might be a good one to practice a second time, because that's a pretty useful question there. Just knowing the bearing in the distance and the bearing in a distance, you can figure out all kinds of stuff about what bearing they would have to take to go straight there, what the distance would be if you didn't take a little side tour there. But does anybody see something about this 52 that jumps out at you that you'd like me to try to clarify for you? Okay, has anybody found any of the others? I know there's not many, but is there any other of the book questions you've tried?
He did 39.
39, you said? Okay, 39 wants us to find area. So, depending on the information given to you, you're given base and height, do 1/2 base times height. If you're given side angle side, use the formula, the 3 formulas we talked about last class. If you're given side, side length, side length, side length, then this is what is referred to as Heron's formula. Your area will come from the square root of S times S minus A times S minus B times S minus C. And then the last thing you need to plug in is S. This is also the true or false question. S is not the average of the side lengths. You don't add them up and divide by 3. It's the semi-perimeter. So you divide by 2. So 2.5 plus 10.2 plus 8 divided in half gives me this for S. S gets plugged in 4 times. Otherwise, I'm going to type that in the calculator exactly the way it looks. And it's an area, so the unit should be square. Again, I really feel like you guys should learn this one in geometry, because it's with the calculator, it's not difficult at all, and it's pretty useful. If you know all 3 sides, that will always work. Okay, if you guys find any other questions on this, please let me know. You got 10 minutes, so there's still time to get some extra help here. But I would like your notes 60 and the book assignment 61 turned in. So I think you should have that done in class, so please go ahead and turn it in. If you forget, I'm sorry, if you don't have time, then just do it before class on Wednesday, please. Wednesday, we'll practice reviewing by mixing up some of the questions. So in 6.1, you only had to worry about law of sines. In 6.2, you only have to worry about law of cosines. And on the review, we'll mix them up. The first question might be law of cosines, and the second one might be law of sines.